Hello everyone, and welcome to webinar Design Strategies Based on Digital Fabrication. My name is Bojan Tepavčević, and I'm coming from the University of Novi Sad, when I'm teaching different courses regarding the digital technology, especially computation design and digital fabrication. Today I'm talking about the digital fabrication and the way how it shaped design thinking. So it will be the topic for today. In contemporary architecture, digital fabrication is not just a tool for the making. It's just it is also tool for thinking, and this will be the main topic for today. So the main aim of this course of this webinar is to explore how fabrication techniques influence the way we design and how tools can shape our creativity. So we'll start from the question, what is actual digital fabrication? And there are many different definitions. I will start from the technical definition that it is just a set of technological process that use digital models to directly control machines such as 3D printers, CNC milling machines, laser cutters, in order to produce some physical artifacts. But it's just technical definition, and in broader sense, in the way of design thinking and from the perspective of architects, we can define digital fabrication as a methodological approach to design and construction, where these digital tools are employed not only for modeling, but also for the fabrication of architectural elements. And why is digital fabrication important for us, designer, architects, industrial designers, fashion designer? The main important thing about that is that it has a very broad application, from experimental pavilions to high-rise buildings, from designing shoes to designing boats or airplanes. And from the point of design thinking, we can say that it has three main directions why it is important. The first one is the most common one, and this is that it creates direct connection between digital models and physical objects. What does it mean? We can see on this example, Terminal Pavilions Oslo, where we can see the 3D model that is precisely modeled, and the process of assembly that can be further used for real process of fabrication. So if we want to create something that perfectly fits, and if we have a complex geometry, digital fabrication is best tool for that. In a traditional construction, mistakes that errors in production process of 3 or 4 centimeters might be a common. But if we are talking about complex shapes and digital fabrication, it has a zero tolerance. So we can create elements that are that has a error that is less than 1 millimeter in order to perfectly fit into some structure. The other branch of design thinking that why fabrication is important is it enables experimentation and iteration in the process of design. And this is one example, a project by Gramazio Koller from the ETH in Zurich, in which they use industrial robots to pour the sands and to make sand ripples. So they actually don't start from final 3D model, but they just create paths for the industrial robot and let the structure to create itself, in order to create some complex sand ripples that will be impossible to make in some other way. So they want to create unpredictable design, not the design that is exact like from the 3D model. And after that, they use concrete poured into this sand. So they just use sand as a cast, and at the end they get the concrete panels that will be digitally fabricated in a way that cannot be done in a different way. And the next approach regarding the thinking is how we can rethink the material through the process of fabrication. As this, for this example, I choose Ducta project. It is a product designed through the process of CNC milling with very dense curves that you can see here. And with these dense curves, material become flexible, so it can bend and adapt to the weight of the someone who sit for this example, for this chair. So the chair, wooden chair, is not anymore tight, but it can become flexible and adaptable to the form. And it can be also adapted in different design scenarios. This is one example of flex map pavilion that is structured in such a way that wood can be easily bent and adapted to the final form. The next question that we can ask ourselves is why is digital fabrication important for the design? And actually, I'd already told, and just to make a summary, that it is because of the direction connection between digital models, then experimentation, as I show with procedural landscapes, and rethinking material design. So the next question that we can ask as designers is how fabrication tools is shaping design thinking. When we talk about fabrication tools, we talk about CNC milling machines, laser cutters, or 3D printing. So the question is, if we use 3D printer, for example, how it can shape our design thinking, and how it can make some constraints in the design process. Before that, I will just make a few explanations about the different fabrication tools and make some categories. Generally, there is a lot of fabrication tools, and all these tools can be categorized in three main categories: additive fabrication, subtractive fabrication, and formative fabrication. And within these categories, we can split in some smaller subcategories. Additive fabrication is probably one of the most popular among architects, especially for create scale models with plastic extrusion. But there is also a lot of different ways of additive fabrication techniques that doesn't include extrusion process, but another process like laminating, powder-based, or light polymerized. But the extrusion process is most popular and probably most important for the architects. Here you can see one example that is done by Netherlands company Actual, and they use computational design tools to create some intriguing geometries like this one, and use process of 3D printing, and use also recycled plastic in order to create these room dividers and other elements for the interior design. So actually they decided to use 3D printing to create large scale, large objects that are designed from reusable plastic. This is another project design together is in collaboration between Actual and architecture studio MVRDV. This is the Tiffany shop in Singapore airport, and this is completely designed in 3D printing. These blue cells-like shapes that are generated as inspiration from the coral reefs that can be found in Singapore Bay Area. And they also decided to choose interesting blue color that is actually Tiffany blue color that as a one kind of branding. For architects, of course, it is maybe the most interesting application of 3D printing when we talk about the concrete 3D printing, because it enables construction industry to go in some another level. We can see here one example, and the thing that we can see here, that the layers that are generated through the process of additive manufacturing is much bigger than layers that we are getting through the process of 3D printing with plastic. And what is more most important, we can design with this way structures that cannot be easily done in concrete, because it would be very difficult to create formwork for concrete if you have wavy walls like this one. This is the project that is currently under construction, and it is the largest 3D printed building in Europe. It is a data center in Heidelberg, and it has the same logic like previous one example. Of course, 3D printing can be used with other materials, and the clay is also very interesting for us, because clay is one of the oldest materials that are used by architects. It is common in architecture for 5,000 years. It is in most of cases used as a brick elements, but 3D printing open new possibilities how we can use and treat clay in architectural design. What is common for all these examples that I show, that we don't have any sharp corners that you can see. So if you see this building structure, or this structure, or this previous structure, or even those one, there are no sharp corners. Especially it is interesting for the concrete and for the clay. And the reason for that is that if you make a large scale 3D print with concrete or clay, you should avoid sharp corners, because in that places where the corners are meet, material can be very sensitive, and it can become some cracks, etc. So it is better to start designing such structure that is already curved. So you don't have corners. Even if you should have to place some corners, you will make some round or fillet on that place. If we talk about subtractive fabrication, it means that we are removing materials from the blocks, and there are different types of machines that we are using if we are talking about subtractive fabrication. So if you are talking about subtractive fabrication, we will use laser cutting, plasma cutting, water jet cutting, or milling, or hot fire cutting if we apply hot fire tool on the industrial robot. So depending on that, what kind of material we want to use. For example, if we want to use stone, then we will use water jet cutting or milling. But if we want to cut metal, we will decide to use plasma cutting or laser cutting. If you just want to make some small scale models from the paper or plywood, we will also use laser cutting. So depending on materials and depending on what kind of design we want, we will choose some machine, or machine will shape our design thinking. In this project designed by Amano Design Office in Tokyo for the Ginza building, architects designed two layered facades. First layer is glass structure, and second layer is metal folding structure, as you can see here. And the metal folding structure is perforated in such a way that it enables viewpoints from the inside, but protect viewpoints from the outside. And what is also most important, that you can see that through the perforation, architects play with the facade in the similar way as graphic designer does. So they use subtractive design approach just to play and create some graphical design, we can say, in such a way. And in the similar approach, we can analyze in another examples. For example, for this museum extension designed by Nietos and Subian Architectus in San Sebastian, in historical center of this city, they create a museum extension of San Telmo Museum that is metal facade with a lot of perforation that creates some intriguing patterns on the facade. So by removing materials, we can get some interesting details. What makes difference between laser cutting and CNC milling is that with the CNC milling we can create relief on the facade. So laser cutting and plasma cutting might be interesting if we treat facade just as a graphical design. So we create two-dimensional drawings and play with that. But if we use CNC milling or want to use CNC milling, we also can play with the relief or depth on the facade or interior design elements. The interesting thing that we have to mention also is that we have a lot of different CNC milling bits, as it is shown in this slide. So for the same path for the CNC milling, we can get different shapes and outlines that are designed. And this is one example what we can do if we use CNC milling. So we can get three-dimensional relief on some wall, as it is case example in this Simon Warhammer design for the Baubuch wall in 2018. So if we want to have a textural quality of the wood, as it is shown in this example, and to have also relief that is three-dimensional like this one, we will choose CNC milling as a tool for the fabrication. Formative fabrication means that through the forces that we apply to some material will adapt and to some another shape. It means that we will now subtract or add material, so we don't have any loss or addition of materials, but material will form itself to some final shape. And there is a lot of different approaches to formative fabrication. I mentioned here some of them, like industrial robot using for then heat forming, fabric forming, vacuum forming, etc. And I will show just some examples to show how it can be applied. In this example, it is used vacuum forming in order to bend a wooden board in such a way to adapt to the negative element that is already fabricated on another CNC milling machine. So we can use vacuum forming if you want to bend some materials. It can be some small things, but it can be also bigger things like this wooden element. And there is also another approach to forming, like casting. In this example, that is called Taylor crate, and it is result as a project of consortium of several universities. They invented a new way how to create free-form shape of concrete with reusable formwork. So one of the main problem for the free-form shapes of concrete is formwork. We already saw that 3D printing can solve that problem, but if we want to apply also some reinforcing elements, casting might be a good solution. And they decide to use reusable wax as a casting material, that they pour the wax into the this box that is already filled with the sand, and the shape of the sand was already adapted to the form with the industrial robot that shaped this form. After that, sand was removed, and also wax was removed, concrete was poured, and they get the final concrete shape of the panels. So casting might be a interesting solution if you want to get a concrete structure that has a nice relief structure, as it is shown in this example. And this is one of the final results in this project. At the Digital Design Center at the University of Novi Sad, where I'm also part of this team, a few years ago, we have also some experiments with process of forming. We use industrial robots to cut the extruded polystyrene, and this extruded polystyrene was used as a negative. So we poured the clay inside, and after that we bake that clay and get clay blocks, clay panels. And in that way, we try to rethink how we can use another way of brick clays that are fully customized with some three-dimensional relief, as it is shown in this sample. Here we can see in bigger detail our final result, that is our product of industrial robot process of baking the clay. And also we can combine all these technologies. For example, architecture studio, the very often combine formative and subtractive technologies. And this is one example just to show it. It's Minima Maxima pavilion shown at the World Expo in Astana. It has a very complex form, as you can see, and this complex form consists of a lot of developable strips. So the process of design includes creating a final form, then split it into a lot of developable strips. After that, all these developable strips should have to unfold into the flat plane. After unfolding, they are ready for laser cutting. After laser cutting, they can be further assembled through the bending process to get the final form as it is shown here. And here we can see the process of bending aluminum developable strips in order to create a final result. The next way of thinking, so we just talking about how fabrication tools like CNC milling or other machine can shape our design thinking. Another approach is how material strategies can shape our design thinking through the process of digital fabrication. When we talk about material strategies that can be used in the process of digital fabrication, there are several common approaches, and I will just talk about that and try to explain in more detail. These approaches are sectioning, folding, forming, and aggregation with interlocking. The first one, sectioning, means that if we have some large object and want to create through the process of fabrication, we can create a lot of planar sections, and through this planar section we can get profiles that can be further grouped and assembled as this is shown in this slide. And this is a project by architecture studio DECOI, and this is the wooden office that is completely designed with the wood with the sectioning process. Here we can see the process of grouping elements that are cut, and after that they are assembled to get the final result. So this is the way how we can create very large structures that are digitally fabricated and fabricated from machines that are much smaller than a structure that we want to design. This is another example that is even much bigger. It is a Metropole Parasol in Seville, designed by Jürgen Meyer-Hermann. And this is one of the largest wooden structures in the world. This is actually some wooden canopy that protects people from the sun, and also protect our archaeological site that is behind that. And also at the top of this structure there is a walking path, so visitors can go up and visit city on the other way. In this project, it is applied sectioning in two directions that are orthogonal. So in that way, if you use section in two directions that are orthogonal, you always can create some form that can be structurally stable, as it is shown in this image. And the thing that is very interesting regarding the sectioning with two directions that are orthogonal, it is often used for creating some substructures or formwork because if we create formwork in that way, we can put some materials that is final here, and it is used for the project Armadillo Vault designed by Block Research Group for the Venice Biennale in 2016. So the main idea here wasn't to design with sectioning, but to use it as a format to place stone blocks, and after the stone blocks that create self-supporting structure are placed, this sectioning structure was removed. So final result is shown in that slide. The only possible way to fabricate a structure like this one, that consists of a lot of stone blocks, that doesn't have any glue or any other elements, is to create self-supporting structure and to have some kind of format during the process of fabrication, and orthogonal sectioning is perfect solution for that. Another approach is folding. Folding is very handy because we can use it with the paper, and the folding means that we can fold some material, so we can take pressure or tension in order on some lines of the paper or on material in order to get final form. If we fold the paper, we can get in some cases structures that are very stable. And folding has received its inspiration from the kirigami and origami. It is also interesting. And also, if we can fold something from paper, the same logic can be relatively easily translated into bigger scale or a different material like metal. For this exhibition in Biennale 2012, Zaha Hadid created a structure called Arum. This is conceptual model for this structure made by paper. And here we can see final structure that was designed by metal processing. So design that is was experimented through the paper was further translated into metal folding. And the next example shows that even the paper can serve as a material for creating experimental structures or large-scale structures if we use folding, because if we use folding, we can create, as I told you, structural stable structure. Here we can see just in detail how this folded elements connect each other and create a bigger structure. This is another example that shows that folding can be also used for the facade design. It is done by Morphosis for the Emerson College. One of the main ideas was to control the amount of light that penetrates through the facade from one side, from the other side to get some intriguing facades. And for the process of design, they use swarm intelligence. They let agents to move freely on that space, and they are constraining some elements in order to get this interesting structure. The next approach is use forming approach, and forming is might be connected with formative fabrication that I already talked. In this example, designed by Zaha Hadid and Block Research Group, that is called Knit Candela, they create tensile structure from the textile, elastic textile, and they use it as a formwork for the concrete. So they pour concrete on the another side. In that way, they get a lightweight structure that is structurally stable, that is actually connects minimal shape with the concrete. And forming might be very interesting for in combination with concrete. Mark Fest from the University of Manitoba experiment a lot with the fabric formwork. This is a forming technique that includes elastic textile and pouring concrete into this textile. So under the gravity and weight of the concrete and some fixed point that's already defined, he can receive final shape that are designed by the forces of the and gravity of the concrete, and he can get interesting concrete panels that can be used for facade design, for example. And the last approach, when we talk about the material strategies, is aggregation and interlocking. The most important thing that we have to mention about aggregation and interlocking is that this material strategy can be fully recycled. We can use only one kind of material, and also we can rethink what kind of material can be used for digital fabrication process. In this project called Rock Print, it is shown on Architecture Biennale in Chicago 2015, Grammatica Color use industrial robots that are placed some strings, and after placing the strings in some pattern, they pour the rocks, and after several processes, actually this is additive manufacturing. It is not 3D printing, but it is additive manufacturing because it creates forms layer by layer. But after removing this form here, and after the gravel that is not connected with these strings go down, they get a final result. So they show that even material like small stone that doesn't have any interesting properties regarding the aesthetics can be shaped in such way to create such structure, and also it is fully recyclable. If we just move the rope, whole structure will be just go down and be destroyed. For this process, you don't have to design, of course, any kind of shape. You can just put the gravel, the stones, and in such way you can get the structure. Opposite approach. Here we can see how tension between strings and the friction of stones create this jamming aggregation process. And the opposite approach to aggregation is interlocking. It means that we again use some kind of creating large structures from a lot of smaller elements, for a very large number of small elements, but and the monomaterial, all materials are in the same way, without any adhesives or glues or something, but in such way that connection between elements are precisely designed. For this experimental structure that I did 10 years ago, this is a small pavilion. I use interlocking process between interlocking elements between triangle elements and this connector, and just through the friction fit connection, I made with my colleagues this structure very stable. After that, we tried with a larger structure like this one and show it at the exhibition for the EKD workshop in Novi 2016. So final result is self-supporting shell that is 2 meters span and with thickness that is only 0.4 centimeters, and it has only interlocking elements as a way how to connect. So it is fully recyclable because we don't, and it is created without glue, without any other adhesive to create such structure. So thank you for your attention, and I look forward to your question and discussion if there are any questions. You can show or also go back to any slide if you're interested to see again. Okay. If there are no questions, I would like to thank you again. And if you have any question, you can send me an email or something. Okay.